Have you ever just stopped and looked around you? I mean, really looked. At the fork you use for dinner? The window you gaze out of? The phone that's probably in your hand right now? These things aren't just there. They are tiny marvels of science, made from materials that we've cooked up in a lab to be something truly extraordinary.
Here's a great example. You'd think pure copper would be the strongest, right? It just sounds stronger. But nope, a bronze metal is way tougher. And that little fact, well, it unlocks a huge secret about how we've built our entire modern world. It all comes down to the science of mixing things up. And that's exactly what we're going to dive into today. We're going to see how just a pinch of one element can completely transform a metal, how we turn simple sand into super strong glass, and how we Frankenstein different materials together to create something better than the sum of its parts. Okay, so let's start at the beginning with one of the most fundamental ideas, making metals better. And that brings us to the world of alloys. The definition sounds pretty simple, but the results are, and I mean this literally, world-changing. Think of it like a recipe. You start with your main ingredient, a base metal, and then you add a dash of something else, and boom, you've completely changed its personality. So what's actually happening here? What's the secret sauce? To get it, we need to zoom in, way in, all the way down to the atomic level. This is where the real magic happens. Okay, so check this out. In a pure metal, all the atoms are the same size, and they line up in these perfect, neat, tidy layers. When you push on it, those layers can just slide right past each other. Super easy. That's why pure metals are usually pretty soft. But when you make an alloy, you toss in some different sized atoms, and you completely mess up that perfect order. And here's the key. Those new, different atoms, they get in the way. They're like little roadblocks. It's like trying to slide a perfectly stacked deck of cards. Easy, right? Now imagine jamming a few thicker, weirder shaped cards in the middle of the deck. Suddenly, nothing slides. That disruption is exactly what gives an alloy its incredible hardness and strength. And this clever bit of chemistry is everywhere. It's in the lightweight duralumin that lets massive airplanes actually fly. It's the stainless steel in your kitchen that laughs at rust. Each one of these is a custom-designed solution for a specific problem. All right, so we've seen how mixing up metals makes them tougher. Now, let's talk about something we see right through but often overlook, another marvel of material science, glass. Believe it or not, almost all glass starts out as silica, which is, well, it's basically sand. But making glass from pure sand is actually really hard and expensive. So naturally, we started experimenting, adding other things to the recipe to give glass all sorts of different superpowers. And this chart really shows you how versatile it is. For everyday stuff like bottles and windows, we add soda and limestone to make the glass easy to shape. But for your Pyrex cookware, we add boron oxide. That creates borosilicate glass, and it's why you can take a hot dish out of the oven and put it on a cool counter without it shattering into a million pieces. Every additive unlocks a totally new skill. Okay, next up, let's talk about a material with some seriously ancient roots, but a surprisingly high-tech future, ceramics. Now, we all know traditional ceramics. They're made from clay, they're hard, they're awesome at insulating from heat, and yeah, they break if you drop them. Think of bricks, pottery, your favorite coffee mug. But that's only half the story. 2,700 degrees Celsius. Just let that number sink in for a second. That is hotter than molten lava. And that is the melting point of an advanced ceramic called silicon carbide. Yeah, we've come a very, very long way from a simple clay pot. So what's the difference? Well, instead of just using clay from the ground, these advanced ceramics are made from incredibly pure man-made compounds. The results are materials so tough and heat-resistant, they're used inside car engines and for industrial cutting discs. They are literally engineered for the most extreme conditions imaginable. So what happens when you take two completely different materials and force them to work together? Well, you get our final category, composites, where the whole is truly greater than the sum of its parts. The whole idea here is teamwork. You have a main matrix material. Think of it as the glue that holds everything together. And then you embed a strengthening material inside it to add the muscle. And the most famous example of this, by far, is reinforced concrete. The concrete itself is the matrix, and those steel bars you see running through it, that's the strengthening substance. And this is where the genius of it all comes in. See, concrete is amazing under compression. You can pile tons of weight on it and it won't crush. but it's terrible under tension. Try to bend or stretch it, and it cracks. Steel is the exact opposite. So by putting them together, you get a super material that can handle both forces. And that right there is the golden rule for all composites. You're not just getting an average of the two materials, you're creating something new that cancels out the weaknesses of its ingredients to become way, way better. And you see this powerful idea everywhere, from the fiberglass in car bumpers where tough glass fibers make weak plastic strong, to your own transition sunglasses. You know how they darken in the sun? That's a composite at work. Tiny bits of silver chloride are mixed right into the glass. When you step back and think about it, from alloys to composites, we have fundamentally re-engineered our entire world just by being clever mixers. It makes you wonder, as we get even better at this, what new recipes are we going to invent? And what incredible things are we going to build next?